Okay, so continuing on with lesson 0.2 about parallel and perpendicular lines. So we already proved parallel lines have the same slope and are distinct. Parallel lines are parallel if and only if they're distinct and have the same slope. Now we're going to go ahead and look at what we can say about slopes of perpendicular lines. So we'll start off with the definition of what perpendicular lines are. Two lines are perpendicular if and only if they intersect at a right angle, meaning 90 degrees. So these two lines are perpendicular. Note that this little box, the little square box right here, means that there's a 90-degree angle in that corner. And if you remember geometry class, you only need to draw one of these boxes, not four of them, because just one means that all four angles are going to be 90 degrees. Alright, those guys, not perpendicular. Clearly, we have an acute angle here, so this one's less than 90 degrees. And so that means that it's not perpendicular. And what about those guys? Yeah, they're kind of close. It looks like they might be perpendicular, but for our class we're going to say that unless they don't have a right angle, just assume that they're not perpendicular. So if they don't have that little right angle mark, I'll try to make sure that that's included whenever you're going to assume lines are perpendicular. Okay, so these are not. Alright, so a corollary to perpendicular lines meeting at 90 degrees is that two lines are perpendicular if and only if their slopes multiply to -1. Now you may have also heard it this way, that their slopes are negative reciprocals of one another. Slopes are negative reciprocals. And that means that you flip the fraction that slope is and you multiply it by -1 and you get the other slope. So for example, a over b and minus b over a are negative reciprocals of one another, meaning the reciprocal flips the fraction, negative sign multiplies by -1. Another way to say this, and I actually prefer this more, is that their slopes multiply to -1, meaning m1, m2, these are our two slopes, you multiply them together, that equals -1. I think it's a little bit simpler, but it means exactly the same thing. Alright, so just like the parallel lines one, this is if and only if, meaning that we've got two directions to look at. Suppose they're perpendicular, show that their slopes multiply to -1, and then the converse means you got two lines that slopes multiply to -1. How can you show that they're perpendicular? Okay, this one we actually don't need a contradiction. We can actually tackle this straight on, and we'll see how that works. It's going to require a little bit of Pythagorean theorem stuff from geometry class. Alright, so start off by assuming we've got two perpendicular lines. We're going to call this one L1 and the other guy L2. So we've got our perpendicular lines, meaning this is a 90-degree angle right here. So 90 degrees. It's a great little piece of a square. Alright, so they intersect at a right angle because they're perpendicular. So they're going to have two slopes. You know, L1's going to have some slope. We're going to call it M1. And L2, L2 is going to have a slope. We can call that one M2. And our goal is to show that we multiply M1 and M2 together, we get -1 out. Alright, so we're going to have a triangle to help us. Now, one thing to note about our proof here is we kind of simplified things a little bit. Not all lines are going to meet exactly, or excuse me, not all perpendicular lines are going to meet exactly at the origin. But that just kind of simplifies our math a little bit for this proof. And we can always kind of take our two lines and slide them so that they do meet at the origin. So this proof is going to work no matter what. So let's go ahead and find some points here. So they're going to meet, what colors do I like? Let's do blue. So they meet here. We're going to call this point C. And then we can draw a right triangle by, oops, go away. Here's our right triangle. Because that's a right angle right there, we're going to call this point A. And we're going to call this point B. And we're going to choose this, we're going to make this line be where this is 1. So this is a coordinate, x coordinate of 1 right here. Okay? It kind of simplifies things a little bit. Alright, so ABC is a right triangle. So it's going to satisfy the Pythagorean theorem, which is, oh, I chose my letters incorrectly. Let's go ahead and fix that. Erase, what are our letters? So AB and BC, AC is our, so this is A, C, and this is B. Okay, right here. So AC squared, the hypotenuse, this is our hypotenuse right here, is equal to AB squared plus BC squared. Okay, so L1 is going to have this equation. I'm going to write it down in red. So L1 is going to satisfy y equals m1x plus 0, because it's going through the origin. And so if we plug in 1, so if we plug a 1 in here, then that's going to give us y equals m1. So this point up here is just 1 m1. Okay? Oops, m1. There we go. And likewise, this point down here, C, is going to be 1 m2. Okay? Because if we were to plug in 1 to our equation for L2, y equals m2x, we're going to also get y equals m2. So we're going to get 1 comma m2 as a point on L2. And then we've got 0, 0. Okay, so what can we do with this Pythagorean theorem thing that we've got written down here? So we're going to find the length of AB. So AB's length, let's see, AB, the length of this is equal to, Pythagorean theorem, this length, it's 1 squared plus, the square root of m1 squared plus 1. So let's try to see why that's equal. So we're going to use this triangle right here. This triangle right here. I'm going to just draw it down here. So this is 1. This is AB. And this is m1. So this length AB here is, the hypotenuse of a right triangle, and so AB squared equals 1 squared plus m1 squared. So that gives us AB equals root 1 plus m1 squared. Okay, so that's where this comes from. Or root m1 squared plus 1, either way. Similarly, for BC, this line down here, we can draw in another triangle. We can draw in another triangle. So it looks something like this. Here, I'll erase this triangle. Okay. So for green, we've got a triangle that looks like that, and this point down here, we're interested in BC. BC. This is again 1, and this is a length of m2, not really the absolute value of m2. And so we can again use the Pythagorean theorem to figure out how long BC is. It's going to be equal to m2 squared plus 1, and the square root of that. And the third length we're interested in is finding AC. So AC, let's go ahead and erase that. Well, AC is part of a vertical line. So here's AC. AC. They have the same x-coordinate, m2, but different y-coordinates, 1, m1. And so to find the length of this, we just subtract m2 from m1. So that means that AC is equal to m1 minus m2, that length right there. All right, so we've got our three lengths. Got AB, we've got BC, and we have AC. And so it's been a hot summer. And so we need to plug these into the Pythagorean theorem and go ahead and figure out what shakes out from that. Okay, so AB squared is this guy, and BC squared, so let's get our colors going. So here's AB, here's BC, and here's AC. So we square all three of these, and we're going to get, the Pythagorean theorem from it. Okay, so what happens when we square each of these? When we square this guy, we're going to cancel the root. So this cancels our root, and that gives us m1 squared plus 1. When we square this guy, we're going to cancel the root again, and that gives us m2 squared plus 1. So we get m1 squared plus 1 plus m2 squared plus 1, and that's equal to m1 squared plus 1 plus m2 squared plus 1. You can see that that's equal to this m1 squared plus m2 squared plus 2, because the ones combine. And when we square this guy over here, the m1 minus m2 squared, let's go ahead and FOIL this out. So I actually need a little bit of space over here to FOIL out that expression. Let's erase. Okay. So FOILing m1 minus m2 times itself. And we are going to multiply m1 times itself and m1 times minus m2, so that gives us m1 squared minus m1 m2. And then the other way, minus m2 m1, so that's again minus m1 m2. And then minus m2 times minus m2 is plus m2 squared. So these two middle terms combine, gives us minus 2 m1 m2, as you can see here. And there's m1 squared and m2 squared. All right, so we're close. We have m1 squared on the left and m1 squared on the right, so we can subtract that from both sides. Likewise, we have m2 squared on the left and m2 squared on the right, so we can subtract that from both sides. So that's going to give us this equation. 2 equals minus 2 m1 m2. And one step away, divide both sides by 2. Divide by 2. Divide by 2. And that gives us, by minus 2. By minus 2. That gives us m1 m2 over here equals 2 divided by negative 2, which is negative 1. And we're done.